Function transformations. Function transformations move the graphs of functions on a coordinate plane. To move the graph to the left, you would add a value to x in the equation. To move the graph to the right, you would subtract from x. To go up, you'd add a positive value to the entire function, and to go down, you'd subtract. When you multiply a number by f of x, you're going to change its distance from the x-axis, so you're vertically stretching or compressing. A vertical stretch would be when k is greater than 1, and a vertical compression would be when k is between 0 and 1. Let's look at some examples. Number 1. Translate the graph of f of x equals x squared and write function rules for each translation. So in the first graph, we're going to be translating the function 2 units up. Now, if we translate the function 2 units up, according to our rules, that means that we need to add 2 to the entire function. So let's make this g of x equals x squared plus 2. And I chose g of x just to make it different from our f of x. All right, for the second one, we want to go 3 units to the left. Now, according to our rules above, if we want to, if we want to go to the left, then we need to add to x. Right here, add to x. So we'll make this graph h of x, and I'll do x plus 3 squared. And then the last one, I'll make it j of x, and it says a vertical compression by a magnitude of 0.5. So that would be 0.5 times x squared. So let's take a look at these graphs. And here's a look at our different graphs. Here we have x plus 2, definitely move this graph up, because as we're looking, let me pull up the parent function. So here's the parent function. So as I was saying, as we are looking at the original at x squared, if it moves up 2 units, and this is, each of these are scaled the same way, so it's one block is 2 units. So it went up 2 units, and its equation is y equals x squared plus 2. So then 3 units to the left, we added 3, moved it left from the original, and then vertical compression by magnitude of 0.5, so you can see that it made it kind of flatter, almost like something was pushing down on it. So how you can tell by looking at coordinates for this is you can pick a point, like here where x is 2, x is negative 2, y is 4. Over here is where x is 2 and y is 4. Well, if we look at where x is 2 here, the y-coordinate should be half. So negative 2, 2. And positive 2, 2. So you can see that the y-coordinates are half, because the scale factor here, the magnitude, is half. All right, number 2. Describe the transformation of the graph of f of x equals x squared, that is graphed to the right in words and with a function rule. So let's go ahead and pull up the graph of the parent function y equals f of x, or y equals x squared, so that we can compare them. Now as I'm looking at them side by side, I see 2 things that have happened. The first is that this graph has been shifted over 2 units to the right, and I know it's 1 block, but we have to be really careful because the x-axis is counting by 2's, and coincidentally so is the y-axis, or intentionally. So it's going over 2 units to the right, and then the graph also looks thinner. So we need to figure out how much thinner it is. So this is a vertical stretch when it gets thinner, and so we know that the equation has been multiplied by a number that's greater than 1. So to figure out exactly what that scale factor is, what the magnitude is, I'm going to move over a few points. I'm going to move them back 2 units just to see where they would be so we can compare them to the parent function. When I say parent function, again, I remember it's just the y equals x squared. So if I move, let's see, this would point up here, and this point up here, just moving everything over 2 units. So I have a parabola, and if I go ahead and list out the coordinates for that parabola, that would be -2, and that's up 8, and +2 up 8. Then if I look at the coordinates for my parent function, parabola, when x is 2, so when x is 2, y is 4, that's -2 and 4 on this side, and +2 and 4 on this side. So I'm looking now at what's happening to y. So y went from 4 to 8, and again from 4 to 8. So the y coordinates are twice as big. So I have 2 things that are happening here. I have a vertical stretch by a magnitude of 2. And I also have a translation two units to the right. So this equation, make it g of x now, so it can be different from f of x. G of x is 2 times x minus 2 squared, where this 2 right here is the vertical stretch, and this 2 right here is moving the function 2 units to the right. Alright, so for number 3, we are describing the transformation of the graph of f of x equals x squared again. And it's translated over here to the right, and we need to explain the transformation in words and with a function rule. So let's go ahead and pull up our parent function so that we can compare them. So here's our parent function. As we look at them side by side, we can see that this graph has definitely moved to the left. Looks like left 3 units, and then up 2 units. So left 3 and up 2. Alright, so let's go ahead and write that out in our words because it doesn't look like the shape has changed. It's not wider or thinner. It's just been a translation. So let's go ahead and write our translation out in words. Alright, so translation left 3 units and up 2 units. Then symbolically, let's see, we'll do g of x, just to be different from f of x. If we're going left 3 units, that would add to the x. Parent function is squared, so I'll keep that in there. And then up 2. And there we have our function rule. So now it's time to pause the video and complete the independent practice. Once you're done with the independent practice, press play to check your answer. For number 1, for the independent practice, we have g of x going 4 units down, x squared minus 4, 2 units to the right, be quantity x minus 2 squared, and then vertical stretch magnitude of 2. Just put a 2 right in front of the x squared. And then for number 2, there's a vertical compression of a magnitude of 0.5, and we know that because when we look at, or when we compare the points for where x was -2, and to see what y was, when we compare that to the parent function, we know that the y values are half. So that means that the function, the magnitude being 0.5, would be multiplied to the x squared.